Hi, I'm David Santiano, and this is my presentation on video game emulation. So let's get started. So, what is an emulator? There are many different types of emulators, but the one that we will talk about here is an emulator that tries to replicate the hardware and software of a full computer, which we will call the emulated or source computer, using only software in another computer, the target computer. This means that the specific CPU architecture of, say, a PlayStation 2 CPU and its interaction with other hardware components will be imitated by using only software on your own personal computer. So, why emulate? An emulator can be used to run software that cannot be run on a traditional modern computer. In this example, the emulator is running video games from an old gaming console, such as a Super Nintendo or a Game Boy Advance. So, how does this work? In order for an emulator to be made, an intimate knowledge of the emulated computer's assembly code must be known in order to reproduce its hardware's characteristics in software. The target computer's architecture can only be known by looking at documentation on its hardware, but most of the time the documentation is not available, and the assembly code has to be learned via reverse engineering or schematics. One of the most important things to remember when building the assembly code of the processor of another computer is how accurate that emulation is. This is important in the emulation of gaming consoles, as the calculations done by their processors are time dependent, meaning that there must be a response to each process done within a strict amount of time. So, the target computer must utilize loads of processing power to retain accuracy as it imitates the emulated computer. In the case of video game emulation, it is more important to have accurate external output instead of high accuracy within the low-level assembly code. This is called a high-level emulator, as it values simulating the response of the system rather than accurately recreating its internal structure. So this leads us to external output. Most video game emulators are high-level and they prioritize external output. External output on a multimedia computer such as a PlayStation 2 requires a reproduction of the sound and graphics of the game being played that is heavily dependent on the accuracy of the software. Accuracy on the target computer is largely dependent on the processing power of its CPU, as it needs a lot of it in order to maintain high accuracy. A good rule of thumb is that you need 10 times the processing power of the emulated computer in the target computer's emulator. If the emulator starts to become too fast, then music and visuals may start to noticeably become faster than normal. With a problem like this, the emulator needs to use CPU power to synchronize with the original timing of the emulated device. And if it becomes too slow, then it has to reduce calculations to rematch the speed. It is important to note that faster does not mean faster as in that it has better performance, but that the game will actually look like it's going in fast forward or slow motion. So the question of it is this legal? Surprisingly, the creation of an emulator is perfectly legal, as you are imitating the hardware of the console via software and not its own software. The software of the console, called the BIOS, is the only part of the console that has intellectual property rights. It is perfectly legal to get the BIOS off of your old PS2 and load it into an emulator downloaded from the internet. The files for the game have to be acquired from your old disks, as downloading games offline would be piracy, which is illegal. So here are some emulators that are currently out. For the PlayStation 2, there's PCSX2. For old arcade games like Street Fighter, there's MAME. For the Nintendo 64, you could play Mario 64 on an emulator called Project 64, or you could play Mario Party. And for the Game Boy Advance, there's Visual Boy Advance, which you can use to play Pokemon games and all sorts of Game Boy Advance games. What's interesting is that these emulators are independent projects done by groups of regular people, not a company. It's very interesting what people can do when they band together. Thank you for watching.